Hey guys, welcome back to another video. This is Mr. K. Today what we're going to be learning about is pretty much the magic of 3D printing. Imagine taking an idea, whether it be a sketch, a drawing, and having it become an actual object in real life. That's the beauty of 3D printing. You can take different things, creations that live in your head, and then bring them to real life, all starting with a simple sketch. Today's video is meant to show you how 3D printing works so you have a better understanding moving forward that allows you to do more complex designs and sculptures in the future. But real things you can hold. That's the beauty of 3D printing. A 3D printer is a machine that builds objects layer by layer, line by line, using melted material. The melted material it uses is called filament, usually a type of plastic called PLA. The best way to think of it is like a robotic hot glue gun with a brain. You would design something in a program like Tinkercad, and then the printer would bring it to life. From toys and tools to medical parts and art. This machine makes it real. So let's get into how it works. It starts with a digital model, a 3D shape that you design. The printer then slices that model into hundreds of layers. It heats up PLA, a bioplastic made from corn, and extrudes it like spaghetti, stacking layer after layer after layer. The technical term for it is called additive manufacturing because it is adding material instead of cutting away. Just to have some buzzwords to listen for throughout this lesson, filament is the material we use to print. This is filament right here. An extruder is the hot part that melts the plastic, which is right here. The build plate is the flat surface where the print happens. The G code is the language the printer uses to understand. There's a lot of cool things that we can make with 3D printers. It has a lot of different use cases, whether that be something like an art sculpture, a planter, but we want to know why this matters. This isn't just about cool gadgets. 3D printing is changing the world. Engineers use it to prototype invention. Doctors print prosthetic limbs. Artists create custom jewelry. Even NASA uses it to make tools in space. Learning this now sets the foundation for designing solutions to real-world problems. So I just want you to take a minute to sit back and think. Let's look at our community. What are some ways that 3D printing could help tweak and benefit and add to our everyday lives? Could you design a better water bottle, a tool to help someone hold a pencil, a piece of wearable art? That's the power that's in your hands when you understand this tech. This is where creativity meets purpose. This specific printer that we have is a Bamboo Lab A1 Mini. We have a collection of different 3D printers here in the lab, but this one is one of my favorite ones, mainly because of its compact size and efficient speed. It's a desktop flat bed slinger printer, a different design compared to like an enclosed space. It's exposed to different elements when you're printing. This is really just a design preference. This printer has a lot of capabilities. Despite the sizing, you really are only limited in the width and like the space you can use it with. It's a smaller radius compared to the larger printers, but it still prints in the same speed as a X1C or any Bamboo Lab printer that you see on the market today. Now that you have a basic understanding of 3D printing and how it works, I look forward to teaching you more in-depth processes about designing and also how to use 3D printing in further endeavors. This printer has so many different capabilities. It also is very fast and efficient. What I'm printing right now is called a benchy, and pretty much what a benchy is, it's a small little boat that calibrates your printer. It pretty much shows you the speed levels and its strength test. This one design has so many different complex angles and there's different overhangs that really test your printer's capabilities and let you know if it's calibrated or not. It's like a stress test, the best way to look at it. So what we're gonna be doing, making a benchy, and I really just wanna go over just the basics of 3D printing as it's happened. So the cool thing about 3D printing and what a lot of people fail to realize is that there's so many different materials and applications towards 3D printing. You really just have to start with a model. Now, when you have a 3D model, there's so much you can do with that model. You can animate the model in softwares like Blender, or you can make it come to real life Tinkercad and then bring it in over to be 3D printed. Now, with 3D printing, you can have so many different materials that you use to print with. The most common one that we use is PLA, which stands for polylactic acid, the same compound that you'd find in corn, and we actually produce this, but it's pretty much a bioplastic that gets made for 3D printing. It derives from corn though. Now, when looking at other materials you can use, it really just depends on your application and what you're trying to do. If I want to make something squishy, I'd use TPU, which is a more flexible material, and it gives in. PLA is a more firm, harder material, but it's not one of the strongest ones that we can print with. It is, however, one of the most cost-effective and classroom friendly, because the more materials you have, you start to realize that some of these materials that to print in have some toxic characteristics. For example, you can print in resin, which is another type of 3D printing, a totally different type of 3D printing. But the cool part about it is that it leaves a different finish, and it is more, it doesn't require sanding or anything compared to these prints, and you don't see the layer lines. So these printers and the printers that you'll come in contact in our class are called filament driven machines, or FDM printers. Pretty much they only use filament. Now you have resin based printers that use resin, which is a chemical that is mixed that allows for just, it comes with a lot more loops and holes to go through. But with this, filament-based printers still have a lot of capabilities. They're ASA or ABS, which is typical for car parts or different machineries like that, for stronger materials that need high levels of heat or heat resistance. You would print in ABS or ASA. And if you're going you need a more stronger material, stronger than PLA and not flexible, you would go with PETG, which is a more durable plastic. Now, let's really just get into how this is actually working. So going back to our buzzwords, we have the filament that is going all the way through here and is connected to the extruder, which is heating up the filament and then allowing it to build on top of each other, layer by layer, line by line. Now, it's building on top of the build plate. The build plate is essentially our workspace area where we can put the designs. Anything outside of the build plate, the printer will not go to. And all this is happening because we sent it to the printer, and the printer broke up our model into G-code, which is pretty much the language of 3D printers. Now, with this in mind, we want to think about different things that are other terminologies that go into 3D printing, or other aspects of thinking that go into 3D printing. This prints with no supports. Now what that means is, with 3D printing, there's these things called supports. You can have regular supports or tree supports. And pretty much these allow for a better success rate with your prints. The more complex the print, the more supports you may need. Now, supports help with intricacies and things like overhangs, or if certain designs peek out and others don't. It allows for it to continue to work layer by layer, line by line, but accounting for it, and then you just break it off once you're done. Supports are very satisfying to break off, but they're very helpful in our overall design process, allowing us to be very intricate and very intentional behind what we design with our creation. Now, this isn't just about cool gadgets. 3D printing has so many more applications, and it's changing the world constantly. Engineers use it to prototype inventions. Doctors print prosthetic limbs. Artists create custom jewelry. Even NASA uses it to make their own tool. Learning this now sets the foundation for designing solutions to solve real-world problems. Now that you have this basic understanding of 3D printing and what its applications are, I'm excited for what you will be able to create in this class. There's a mix of different things we'll learn, and we really want to be fully engaged and be able to tackle this with a full head of steam. So this printer has 4 different speeds: standard, silent, standard, sport, and ludicrous. Right now it's on standard, but if I were to do this, it starts printing faster. And the benefit of this too, it cuts the print time in half. So it goes from taking about 9 minutes to print to about 4 minutes. This is why I like this printer. And this is the future of 3D printing, because machines like this are only gonna get better. They're only going to advance. And if this is one of the levels, I can only imagine where the future of 3D printing will take us. So designs and things that would usually take hours to make are now being able to be created right in front of our eyes. So really, when you look at 3D printing, you really want to look at it as a bridge to greater understanding and more creative endeavors along the lines. Let's get to your mini maker challenge. Your challenge: design your own custom keychain in Tinkercad. Make it say your name, a word that inspires you, or your dream job. Keep it small, keep it bold, and print it out, and let's see your idea become reality. The future is yours to make.